let's continue to exercise 4. So for exercise 4, the Z and also the S-axis respectively carry filamentary current of 20 ampere. So this then means that for Z-axis it has a filamentary current of 20 ampere as well as the X-axis. Okay, so their direction is positive Z direction and also the positive X direction. And for the current filament, okay, that is along the x-axis, its magnitude is 30 ampere. So you have to calculate the H at this position. Okay, first of all, you need to draw this current filament out. So this is your current filament. Okay, this is the current filament in the positive Z directions, current filament in the positive X directions. These are their magnitudes. You label it, and this is the position P. Okay, 6 at -6, where you need to find the magnetic field. So for infinite current filament, in this case, you don't know where is the starting point, and also you don't know where is the ending point. So in this case, we can use the formula for infinite line, these equations. Okay, this is the equations. Here you need to find what is the magnitude of R. Okay, so we have to do it separately, one by one. Let's focus on the current filament along the Z-axis, this one first. Okay, so first of all, we need to determine what is the point T. Okay, what is the point T? Okay, point T is the point that is located along the Z-axis, okay, along the current filament. So it has the magnitude of X and Y equivalents to 0. So for the value of position Z, you just follow the value of the observation point, which is -6. So here you have 0, 0, -6. And when you need to find the vector R, okay, you take the observation point minus the source point, okay, the point T, then you will get this one. Okay, this stands for 6x and 8y. Okay, so next you find is magnitude and also the unit vector R. Okay, next is to replace, okay, all the values that you know into the equations. You have the I, you have the R from here, and this one is the direction of the current flow in the positive Z directions. Cross product with this one, okay, unit vector R. So Zx you will get positive Y, and Zy you get negative X. Okay, so you can calculate the value by using the calculator. So this is the magnetic field, okay, which is due to the current filament along the Z-axis. Next, we move on to the current filament, okay, in the X direction. In the X direction, okay, again we will use the same equation, but here we need to determine a new T, okay, a new T. So let's look at our I, okay, in the X directions. Okay, so the T point will be located along this line, but you are not sure which point. So all the points here, it has the Z value 0, Y value also 0. So for the X value here, you need to take the X value same as the X value of the observation point, which is 6. So your point T will be 6, 0, 0. 6, 0, 0. Your vector R will be observation point minus point T. So you get this one, stands for 8x minus 6z, 8y minus 6z. Okay, you see this bracket, right? This bracket represents that the component here is actually a vector component, and the magnitude will be 10. You can calculate. Okay, 64 plus the 36, and then you square root it, you get 10, and this is their unit vector r. Again, you put into the equations. This is your I, this is your r. Your r is from here, and this is the direction of the current flow in positive x directions, and this is the vector r. You put it here. Okay, for x, y cross product, you get z, and for x, z, okay, you will get negative y. But here you have one more negative, so it becomes positive y. Okay, so now this one will be the magnetic field due to the current filament flowing in the x directions. So in order to find the total magnetic field at that position, you need to add, okay, you need to sum, okay, the magnetic field, okay, in the x directions, and also the magnetic field in the z direction. Just add them up according to their directions. So x component will be added together with the x component. Okay, z will be with the z, and y will be with the y. So this one will be the total magnetic field, okay, at the observation point P. Okay, so let's continue the remaining exercise. So now you have homework 1 and also the homework 2. So let's look at homework 1. You have a semi-infinite line with current of 4 ampere begins at the positive infinity of z-axis. You have to understand this sentence. This means that you have a semi-infinite line and the current is 4 ampere begins at the positive z-axis. Okay, it is bent toward the positive x-axis at the origin and stop at this point. Okay, so when the current filament extends from positive infinity, okay, it will stop at the origin first. After that, you bend it, okay, to the positive x-axis direction, and it stops at this position. So you have to find the magnetic field at this point. Let's look at the drawing. Okay, it will be something like this. So current filament from the positive infinity of z-axis, okay, and it extends until it stops at the origin, and it bends towards the positive x-axis directions and stop at point 400. The current is 4 ampere, and the observation point, okay, the observation point is this one, -3, 4, and 0. So for this case, you have to split your current filament into 2 sections. Okay, that is section 1 and also section 2. Even though it is the same current filament, but for this case, you have to split it because they are in different directions. Okay, so for line 1, okay, line 1 is a semi-infinite line. Okay, you know where is the point you stop, and you don't know where is the point you start. Okay, this is a semi-infinite line. So as usual, you need to find the r. Okay, so before you find the r, you need to find the t. So your observation point is -3, 4, 0. So point t should be along this line. Okay, so it has coordinate x 0, coordinate y also 0, and for the coordinate z, you have to follow the coordinate z of the observation point here, which is also 0. So your point t will be 0, 0, 0. And for the vector r, you take the observation point minus the point t, and you get this one, which is -3x plus 4y. Okay, after that, continue to find the magnitude of vector r. Okay, and this is the unit vector r. Okay, so here I redraw. Okay, I redraw the diagram. So this diagram is drawn in 2D. Okay, so it will be easier for you to illustrate. This is point T, which is 0, 0, 0, and this is observation point, which is -3, 4, 0, and this is point B, which is extend to infinity. Okay, so for alpha 1, okay, is the angle that attached to point A. So here I label is point A because it has smaller value compared to point B, which is extend to infinity, and this one will be your alpha 2. Okay, when your B is extend to infinity, your alpha 2 will be approximate to 0, and your alpha 1 is 90 degrees. Okay, it's 90 degrees. It is the same as the condition of the angle for this semi-infinite line, and its equation is this one. Okay, so in this case, you no need to apply this equation, but you can apply this equation directly. Okay, so for your phi, it is from the DL cross product with the unit vector R. This one will be the direction of the current flow in the negative Z directions, and you cross product with the unit vector R. So ZX, you get positive Y, and for the ZY, okay, you get negative X, but here you have negative. As a result, you get positive X. Okay, lastly, you can plug in. Okay, you can plug in the angles. Okay, just now I mentioned you no need to use the angle, right? But you can also use this one. Okay, you can also use this one. Okay, in order to find your answer, you will be the same. Okay, so this is your current, this is your R, this is your alpha 2, alpha 1, and also the unit vector phi. You get this one as your magnetic field at the observation point, and remember to put the unit ampere per meter here. Okay, next we move on to the line 2, which is along the x-axis, line 2. So we need to find is R. Let's examine the line 2. This is line 2. So for line 2, it is a finite line because I know the starting point is from 0 and the ending point is 4. So in this case, okay, you have to use this equation. Okay, because it is a finite line after we split the infinite current filament, semi-infinite current filament into two. This one will be a finite line. So for finite line, okay, along the x-axis, okay, its x value, the t, the position t, the y position for the coordinate t will be 0, and z also will be 0, and the x will be follow the x of the observation point, -3. As a result, you get 4y for your vector r, and your magnitude will be 4, unit vector r will be y. So I draw again, okay, I draw again the position, okay, in 2D. So here is the point A, I label it as 0. This is point B, I label it as 4, okay, because the current filament start from 0 until 4. And this is your point T, okay, point T, and unit vector R, okay, unit vector R in these directions. And from the calculation, I know the length here is 4, and this is alpha 1, and this is alpha 2. And from the definition of coordinate t, I know that, okay, it is -3, so which means that the distance, okay, in between the t and A is 3. This will be your alpha 2. So for alpha 1, it will be 4/3. So remember, when you define the angle, you can just forget about the negative because you only concerned about the length, okay, the length or the distance. So you get 53.13 degree. And for the tangent alpha 2, Okay, this is your alpha 2. You have to refer to the big triangle here. So it will be 4 over 7. So here is 3. From here to here is 4. That's why it is 7. You get this 29.74. Okay. Lastly, you plug in your equations. You plug it into your equations. Okay. This is I. This is R. Alpha 2. Alpha 1. Okay. And this one will be your unit vector phi. This is the direction of the current flow in positive x. And this is the unit vector R. You get it from here. And you get this one. Okay, for the magnetic field contributed by current filament flow in the x directions. Okay, in order to find the total H, okay, same like the previous exercise, you have to add them up. Okay, just find the summation, okay, of the magnetic field. This one plus this one. Okay, you get this one as your total magnetic field. Okay, so for the homework 2, I want you to try. Okay, so here you have a square conducting loop. Okay, 3 cm on each side carry a current of 10 ampere. So here they didn't mention about the coordinate. Okay, so you can assume it yourself. Okay, as long as the side of the conducting loop is 3 cm. So you have to calculate the magnetic field intensity at the center of the loop. So in this case, the center of the loop can be at the origin. It depends on your assumptions, and also you can make the sides to be start from the origin also. So I need you to try to finish this exercise. So I will provide, okay, the Google form for you to answer. Okay, and at the end I will share with you the solution.